So this week we have started with our new lesson, which is probability, but with calculation. So last week we talked about um, what's the meaning of a probability, but we remember together what's the meaning of an event, of a sample, of elementary event, file event, all of these terms that we have learned in grade 10. But this week we have started with probability. What's the meaning of a probability? And we said that probability is the number of favorable cases over the total cases all. And we said that probability, it's a number between 0 and 1. It cannot be negative and it cannot be more than 1, because we said that probability, it's actually 100%. The sample space is 100%. So it's 1. So it's 1 out of 1. So it could be maximum of a value 1. Okay. For example, suppose I'm tossing a coin. What are the possibilities of a coin? It's either tail or head. So the probability to obtain a tail, it's 1 over 2. And the probability to obtain a head, it's also 1 over 2. So these cases, 50%, 50%, it's the probability, okay? But if we have a fair die, you know that the fair die contain numbers from 1 to 6, okay? Each number of these, it's 1 out of 6 because we have 6 cases. So this is the probability, the number of favorable cases or over the total number of cases. Also, we said that probability of all the sample space, as I told you before. So suppose suppose we have a class that contains girls, and I said I need a girl. So what's the total number of favorable cases? It's the all girls over the whole class, which is also the whole girls. So the probability of the sample space in this case is 1, okay, because I'm taking the whole sample space. An easier example, suppose I have a fair die, as we said before, it's any number between 1 and 6, okay? And I'm telling you I need to obtain a number less than 7. It could be 1, it could be 2, it could be 3, it could be 4, 5, or 6. So all the cases are my favorable cases. So it's 6 out of 6, which is 1. But an opposite to sample space, it's the impossible event. Suppose I'm asking you, we have a fair die, and what's the probability to obtain number 7? It's impossible to have number 7. So probability of 7 itself, this event is 0 because it's 5. And we already explained what's the meaning of an intersection. So the intersection, it's the common number between A and B. But if we don't have an intersection, as you can see here in the sample set, we don't have an intersection. So the probability of A intersection B in this case is 0. The set A intersection B is 5, but the probability of A intersection B is 0. Also for the union, as you can see here, we have A, which is 2, 4, 6. We have B, it's 3. What's probability of A intersection B? It's only one number out of 6. Pay attention. You never change the sample space. So the probability of A intersection B is 1 out of 6. And you have to know this very well. The probability of the union, A union B, is equal to probability of A plus probability of B minus their intersection. Also, probability of A intersection B is equal to probability of A plus probability of B minus their union. And you still remember the incompatible event, the incompatible events where the intersection is 5, then probability of A union B is only probability of A plus probability of B without the intersection. Probability of the complementary event. This is an important one, okay? If I have A, what's A bar? A bar is all the elements that are not found in A in the sample set. So you cannot find an intersection between A and A bar. So A intersection A bar is 5. And A union A bar, if you join A and A bar together, you're going to get the sample set, all of it, okay? So the probability of A intersection A bar is 0, and the probability of A union A bar is 1. And now we have probability of A plus probability of A bar equals to 1. Or if you have probability of A and you need to calculate probability of A bar, you do probability of A bar equals 1 minus probability of A. Okay, so we say that A and A bar are complementary. The same thing if we have probability of at least 1. Okay, so probability of at least 1 equals 1 minus probability of no one. So at least 1 and no one, they are bar to each other. So we can also use this property and probability of at least 1 and probability of no one. So that's our lesson in general. So this is the summary. The sample set, probability of a sample set is 1. Probability of phi equals to 0. Probability of A union B equals probability of A plus probability of B minus their intersection. If we don't have an intersection, we say that the two events are incompatible. So we cross out the intersection. So only left probability of A union B equals probability of A plus probability of B. When we have a complement of an event, probability of the complement is 1 minus probability of the event itself. So that was our lesson. We just explained it. We didn't solve any exercise yet. Starting from Monday, of course, we are going to solve a lot of exercises together. I'm just going to do one exercise like orally. I'm going to do, for example, suppose you have the two events, probability of A equals 0.3 and probability of B is 0.6. How can I calculate probability of A bar? Probability of A bar is 1 minus probability of A. So 1 minus 0.3 is 0.7. What's probability of B bar? It's 1 minus 0.6, so it's 0.4. They want probability of A union B if A and B are incompatible. What's the meaning of incompatible? Incompatible means that their intersection is zero. We don't have an intersection. So probability of A union B is the probability of A plus probability of B, so it's 0.9. In this case, we need to calculate the union if we have the intersection. I'm going to solve it, sorry for you. So we say that probability of A union B equals probability of A, okay, plus probability of B minus the intersection, okay? So probability of A is 0.3 plus probability of B is 0.6 minus their intersection they gave us. Okay, so it's 0.9 minus 0.15. I'm going to do it. 0.9 minus 0.15, which is 0.75, okay? So this, this is one of the exercises that I'm going to solve next week. Of course, we are going to solve a lot of exercises, okay?